Namaskaram students. In electrochemistry today we are going to see the variation of molar conductivity with the concentration for strong electrolyte and weak electrolyte. What is strong electrolyte? Strong electrolyte means in water it fully dissociated. For weak electrolyte means it is partially dissociated. So for that strong electrolyte and weak electrolyte, what happened the molar conductivity with the concentration we are going to learn. The next one, Debye, Heckel and Onsager equation. This equation we will get when the interatomic attraction between the ions in the electrolyte. The next one, Kolraush law. The Kolraush law, what is the basis means? Limiting molar conductance. What is limiting molar conductance means? With the dilution, whenever the water is added, the weak electrolyte is partially dissociated as a ionoma, that is fully dissociated. When while adding water, that electrolyte fully dissociated, that is called as at infinite dilution, the molar conductance is called as limiting molar conductance. It is the basis for Kolraush law. So what is the application of Kolraush law means? We have three application. One is molar, limiting molar conductance. This symbol indicate that it is limiting molar conductance for the weak electrolyte. We are going to calculate with help of Kolraush law. The next one, alpha means it is degree of dissociation of weak electrolyte. We can calculate with the help of Kolraush law. The next one, KSB, strongly soluble salt, the solubility product. We have learned already in ionic equilibrium. KSB means solubility product for the strongly soluble salt. That can also be we can calculate with help of Kolraush law. The next one, we are going to learn the electrochemical cell. There are two types of electrochemical cell. One is galvanic cell, another one is electrolytic cell. In galvanic cell, the chemical energy is converted into electrical energy. That is called as galvanic cell. The next one, electrolytic cell. Here, the electrical energy is converted into chemical energy. So, there are two types of electrochemical cell. One is galvanic cell, another one is electrolytic cell. The next one, Daniell cell. It is the galvanic cell. The Daniell cell construction, notation, EMF of this cell we are going to learn in this video. Rest of the lesson in PPT.
Variation of molar conductivity with the concentration. Frederick Kolraush, he conducted a test between the concentration and molar conductance in the different type of electrolyte. For that, for example, in this table, sodium chloride, potassium chloride, HCl, they are different electrolyte. For that different concentration, he calculated different molar conductance he got. For the different concentration, he got molar conductance different value. Afterward, he draw the graph between the molar conductance symbol, that is called as uppercase lambda. The inverted V is called as uppercase lambda, and then concentration of the electrolyte. He got one equation. See that equation 9.11, that is uppercase lambda is equal to that uppercase lambda 1 degree is given norma, that is called as limiting molar conductivity. The limiting molar conductivity symbol is uppercase lambda, and above that we have to put 1 degree minus k square root of c. Here the k is a constant value, and then square root of c. Now he got one graph. That graph is a negative slope. Negative slope means when the concentration is increases, the molar conductance value is decreases, or otherwise the molar conductance is increases when the concentration is decreases. So that only it get the negative line. So it is for the straight line. What is the equation there? Y equal to mx plus c. When y equal to mx plus c, you correlate with the equation 9.11. we get that the slope value is minus k. The slope value is minus k, where the straight line intercept at the y axis, it gives the value limiting molar conductivity. What is limiting molar conductivity means? When the concentration is decreases, the molar conductance value is increases. And then how can you decrease the molar concentration value? By adding water. So by adding water means it is called as diluted. So in very dilute condition, that concentration is decreases, at that time the molar conductance value is increases and reaches the some highest point. That point is called as limiting molar conductivity. You see that graph from the graph only you can understand the points. Now we are going to see the strong electrolyte. What is the relationship between the molar conductance and concentration? Now see the graph. The violet color indicated that it is strong. It is for the strong electrolyte. The weak electrolyte, that rose color line indicated that it is a weak electrolyte. So we strong electrolyte we are getting a straight line. For weak electrolyte we are getting a not a linear line. It is a curve line. So now we are only concentrating in this slide only the strong electrolyte. The strong electrolyte, the molar conductivity is very low at high concentration. Why it is low means because of two factor. One is the high concentration means the number of ions. The number of ions of the electrolyte are high. So that ions having the attractive forces also between the attractive forces between the ions also high. That is one point. The second point is there is the ions experience they experience some viscous drag because of greater solvation. So it is a second point. Because of these two factors, they have low molar conductivity at high concentration. Now dilution. Dilution means slowly we add water means the concentration is decreases. So because of decreases, the number of ions are moving apart. They slowly moved between the ions. There is some gap, so that the attractive forces is decreases. If you add more number of water means that is infinite dilution, the distance between the ions or increases, so that there is the interaction between the ions is unimportant. Insignificant means unimportant, so that the molar conductivity, the ions are now free now, where at infinite dilution the ions are very free because the distance between the ions is very long, so that the attractive force is less, then molar conductivity is increases at a maximum level. When means at infinite dilution, you see the graph that concentration is decreases means in y-axis they reaches the highest point, that is called as at infinite dilution. That is uppercase lambda, that is limiting molar conductivity. Uppercase lambda degree symbol is called as limiting molar conductivity. Now we are going to see the weak electrolyte. Weak electrolyte, you see the graph, it is a curve line. Then when the concentration increases, that line is parallel to the concentration axis. When the concentration value is decreases, the curve is parallel to the molar conductance axis, that is y-axis. So it is that the dissociation of weak electrolyte, it is increases when the water is added, because strong electrolyte means it is fully dissociated, but weak electrolyte not like that. Weak electrolyte partially dissociated, so we have to dissociate full means what we have to do, we have to add more number of water, then only the weak electrolyte dissociated fully. So this one we already studied in our Ostwald dilution law. So Ostwald dilution law only for weak electrolyte. So strong electrolyte we can get the limiting molar conductivity value. How can we get? Just you the straight line, you extrapolating the straight line, it meet one point at y-axis. That point is called as limiting molar conductivity for the strong electrolyte. But in that rose color, it is for weak electrolyte. That weak electrolyte, it is parallel to the y-axis, so it never meet the y-axis. Then how can you find the limiting molar conductivity for weak electrolyte? With the help of Kolraush law, we will study later. When water is added in electrolyte, they fully dissociated. The interaction between the ions are important, that is negligible. So some scientists, they study the influence of ionic interaction with the conductivity for the strong electrolyte. They are Debye and Heckel. They consider that each ion is surrounded by some ionic atmosphere of opposite sign, so that the molar conductance of the strong electrolyte with the concentration, they assumed for complete dissociation. Strong electrolyte means we know that it is completely dissociated. Then the equation, it is developed by Debye. It is also developed by Onsager. The another scientist name is Onsager. They developed for equation univalent electrolyte. For example, sodium chloride. Sodium has +1 valency and chlorine has -1 valency. So it is called as univalent electrolyte. There are so many electrolytes there. Just for example, I gave sodium chloride. For that, they given the equation 9.12, that is uppercase lambda is equal to uppercase lambda naught. We can say that degree is a naught also. So uppercase lambda naught minus a plus b uppercase lambda naught and square root of c. In this equation, the uppercase lambda is called as molar conductance and uppercase lambda naught is called as limiting molar conductivity. Then AB are called as constant. These constant depends on the nature of solvent and temperature. They may vary. And then the constant we have to find out the constant value by the following formula. A is equal to 82.4 divided by square root of dt eta. Then B value we can find out by 8.20 into 10 power 5 divided by cubic square root of dt. And what is D means? It is a dielectric constant of the medium, and eta is the viscosity of the medium. It can be varied, so that based on the medium is solvent, the D and the eta value will vary, and T means temperature. It is measured in Kelvin. Kolraush law. Before enter into the Kolraush law, first of all see the symbol. In equation there is two different type of symbol is given. One is lowercase lambda. Lowercase lambda means the molar conductivity for the ions, and uppercase lambda, it is for the molar conductivity for the electrolyte. See the first equation. The electrolyte is given as sodium chloride. That sodium chloride, when you put in water, it split into Na plus Cl minus. So for Na plus, molar conductivity is given as the smaller case, that lower case lambda Na plus. That lower case lambda Na plus means it is a molar ionic conductivity. Then chlorine minus, it is also given as lower case lambda. So it is for the molar ionic conductivity. Now that uppercase lambda sodium chloride means what? Sodium chloride is a electrolyte. Now from the formula you can say that the molar conductance, limiting molar conductance of the electrolyte is equal to the molar conductance of the ionic. This is the Kolraush law. So sodium chloride like this. Suppose we have some other salt. For example, aluminum sulfate. What is the difference between sodium chloride and aluminum sulfate? Sodium chloride, it is a univalency. Sodium plus and Cl minus, both of one having +1 -1 univalency. But in aluminum sulfate, the aluminum possesses aluminum 3+. The valency of aluminum is 3+, and sulfate valency is 2-. But from the salt, you see that aluminum, how many aluminum is present in the salt? 2 aluminum. So 2 Al 3+. The 3+ is a valency of the aluminum, but how many aluminum is present? 2 aluminum is present in the salt. So we get 2 aluminum 3+ ions in the water. And then sulfate, from how many sulfate is present? 3 moles of sulfate. So 3 sulfate 2- ion we get in the water. Then the smaller case lambda of aluminum 3+, how many present? 2. And then smaller case sulfate smaller case lambda of sulfate 2 minus, how many it is present means 3. So we are adding these two, we can get the molar conductance, that limiting molar conductance of the aluminum sulfate. What is aluminum sulfate here? Electrolyte. So molar conductance of the electrolyte we can get from the ions of the molar conductance of the individual ions. When we add the individual ions of the molar conductance, we get the molar conductance of the electrolyte. Then we can generally write that for the general salt AXBY means that X goes to B and Y goes to A. So A valency is AY plus and B valency is BX minus. And how many A is present means X, and how many B is present means Y. So that we have to put in front of the A is X and in front of B is Y. Then generally it is right that AXBY is the electrolyte and then it gives the ions. How many ions it gives? XAY plus. And how many BY minus we get? Y. So that it is writing that sum of that ions of molar conductance give the molar conductance of the electrolyte. So the Kolraush law is the base is only the limiting molar conductance value. We are deriving the limiting molar conductance value. So far I said about the limiting molar conductance. What is the limiting molar conductance? Limiting molar conductance means the electrolyte they fully dissociated on that condition. So it reaches the concentration value decreases means the conductant value it reaches the highest value, that is called as limiting molar conductance. When it reaches the limiting molar conductance, when the concentration is decreases. How it is decreases? By adding water only the concentration is decreases, so that it is called as at infinite dilution. Okay amma. Now see the tableau column. First of all, potassium chloride and sodium chloride conductance value is given. Difference we find means we get the value 23.41. The another one, potassium bromide, sodium bromide. The molar conductance value difference we get the value 23.41. The same way for potassium nitrate and sodium nitrate. In this one also we are getting the difference 23.41. The molar conductance difference is 23.41. Why? What is the reason behind that? There the electrolytes are different only. The conductance value also different one. But the difference between that molar conductance give the same value. What is the reason behind that? Means first of all, the potassium chloride, sodium chloride, see the left hand side, how can you split the potassium chloride? K plus Cl minus, and then sodium chloride also Na plus Cl minus, so that the Cl minus value will be cancelled. We get that lambda, smaller case lambda K plus minus smaller case lambda Na plus gives the value 23.41. So here the potassium and sodium plus only give the value of 23.41. Then another one, potassium bromide, sodium bromide, bromine will be cancelled and then K plus and sodium plus only remains there. This only gives the value of 23.41. And third one, potassium nitrate, sodium nitrate also, it has K plus and Na plus and NO3 minus will be cancelled so that the difference is given by the K plus and sodium plus. The same way for the we can calculate for sodium chloride and then sodium bromide. Here sodium chloride, sodium bromide means how can you split? In the right hand side they given potassium bromide and potassium chloride. The potassium bromide split as here K plus Br minus, potassium chloride split it as K plus Cl minus, which will be cancelled means the K plus will be cancelled and difference between Br minus Cl minus gives the value 2.06. This, so here the difference value is given by Br minus and Cl minus. So that from that we are going to conclude that at infinite dilution each ion from the electrolyte they give the definite contribution toward the molar conductance of the electrolyte, and irrespective of nature of the other ion. Irrespective of nature of other ion means from the example you can understand. In potassium chloride, sodium chloride, which one is having same one? The Cl minus is same one, but sodium plus K plus is different. First application of Kolraush law. Acetic acid CH3COOH is a acetic acid. It is a weak acid and weak electrolyte. For that molar conductance at infinite dilution we cannot find out experimentally. In that purpose we can use the Kolraush law to find out the molar conductance of acetic acid. So we are going to use the strong electrolyte HCl, sodium chloride and sodium acetate. First see the first equation. The molar conductance of sodium acetate dissociated and give the ionic conductance sodium plus and then acetate ion conductance. Then HCl, it is molar conductance of HCl electrolyte gives that we can find out from the sum of H plus molar conductance and Cl minus molar conductance. And then another one sodium chloride. We can get the sodium chloride molar conductance from that the ions sodium plus ion plus Cl minus ion molar conductance. This is equation 3. Now the first two equation I am going to add and then subtract the third equation. So first two equation means sodium plus CH3COO minus and H plus Cl minus. Afterward third equation means minus Na plus minus Cl minus. So which will cancel each other means the sodium plus and another one the lambda sodium plus minus lambda sodium plus. The same way the Cl minus lambda Cl minus minus lambda Cl minus will be cancel each other. Now we get lambda H plus and lambda CH3COO minus. Adding together we get the molar conductance of acetic acid. So Kolraush law is used to find out the molar conductance at infinite dilution of the weak electrolyte. The next application is degree of dissociation of weak electrolyte. We can calculate from the Kolraush law. What is the symbol for degree of dissociation? Alpha. That alpha we can get from the molar conductivity of given concentration, that is uppercase lambda m divided by molar conductivity at infinite dilution. The symbol is uppercase lambda naught. Then from the degree of dissociation, not degree of dissociation, from the degree of dissociation as well as the molar conductant value we can calculate the dissociation constant value also. So according to dilution law, the formula for a dissociation constant is equal to alpha squared C divided by 1 minus alpha. We have already studied this equation in this Oswald dilution law. Then substitute the alpha value in this equation. We get the Ka value at last is equal to uppercase lambda squared C divided by uppercase lambda naught into uppercase lambda minus uppercase lambda. We can calculate the solubility product of the strongly soluble salt from the molar conductance value. First of all, AgCl, it is a strongly soluble salt, gives Ag plus and Cl minus. First of all, write the solubility product is equal to concentration of Ag plus into concentration of Cl minus. Then the concentration of Ag plus is C means then Cl minus concentration also C, because it gives each univalent ions. So that Ag plus concentration C means the Cl minus concentration also C. Then solubility product we get that C into C, C squared. Afterward we in this the first video we already learnt the molar conductance formula kappa into 10 power minus 3 divided by C. From that we can derive the C is equal to kappa into 10 power minus 3 divided by uppercase lambda naught. Then substitute the C value in the solubility product. What solubility product we are getting is equal to C squared. So solubility product is equal to kappa into 10 power minus 3 divided by uppercase lambda naught the whole squared. This is the solubility product. From that molar conductance value we can calculate the molar conductance at infinite dilution. What is that molar conductance? Uppercase lambda naught means it is a molar conductance at infinite dilution. From that value we can calculate the solubility product. Electrochemical cell. In this cell the chemical energy is converted into electrical energy, or the electrical energy is converted into chemical energy. In that cell it has two separate electrode. That electrode contact with the electrolyte solution. There are two types of electrochemical cell. One is galvanic cell, another name is voltaic cell. In this cell the spontaneously it produces the electric current with the help of chemical energy. That is, chemical energy is spontaneously converted into electrical energy. It does not require any initiation for the reaction, so that it is called as spontaneous. It is occur on its own. On its own it gives the electrical energy. For example, battery. The next one, electrolytic cell. Electrolytic cell means the electrical energy is converted into chemical energy, but this cell needs some initiation, so that it is called as non-spontaneous reaction. So to produce chemical energy means we have to give the initiation for this electrolytic cell. Now we are going to see the galvanic cell. Before that, in 11th standard itself we studied that a zinc metal is placed in the copper sulfate solution. What is the color of copper sulfate? Blue color. The blue color solution is slowly fades, and copper metal it is deposited on the zinc metal, so that we get the brown color. Is deposited on the zinc metal. What is the reaction in this one? The zinc metal Z10 plus copper sulfate CuSO4 gives the zinc sulfate plus copper metal. In this reaction, it is a spontaneous chemical reaction, and then some of the energy is evolved. That energy is lost in that surrounding. So that energy we are going to use in this galvanic cell to produce the electrical energy. The energy produced in the chemical reaction is converted into electrical energy. So okay, what will happen here means the zinc already in metal state, it losses 2 electron. So loss of 2 electron means it is called as oxidation, and zinc becomes zinc 2 plus. So in metal both the one same, which both ones, one the electron and proton, both the one having same number. When electron losses means which one is having more amount? The proton having more amount. How many amount more? 2, because 2 electron loss means 2 proton will be more, so that we are putting Zn 2 plus. And in the copper sulfate, copper is a 2 plus valency. It gains 2 electron from the zinc, so that it becomes a neutral one, so we get the copper metal. So here gaining of electron means reduction. In this reaction we get some energy that energy only converted into electrical energy in the galvanic cell. That galvanic cell function we can understand from the Daniell cell. How the Daniell cell is constructed means it has two off cell. That half cell means one is anodic compartment and another one is cathodic compartment. We will see the diagram in next slide. Anodic compartment means it contains zinc electrode and zinc sulfate electrolyte solution. Cathodic compartment means it contains copper electrode and copper sulfate solution. An anodic compartment called as oxidation because in anodic compartment it loses 2 electron, and cathodic compartment it gains 2 electron, so it is called as reduction of cell. Gaining of electron is called as reduction. The next one, the two off cells are, they are connected by voltmeter and also switch. Then electrolyte solution, that electrode are connected by voltmeter and switch but electrolyte solution they are connected with the help of salt bridge. You can see the diagram, you can understand that electrolyte solution they are connected by salt bridge. That salt bridge containing agar mixture and potassium chloride and sodium sulfate. The potassium chloride and sodium sulfate are inert electrolyte. Why we are putting this inert electrolyte means to maintain the electrical neutrality in the electrolytic solution. In this slide we are going to see the construction of Daniel's cell. See the left hand side, green color beaker containing zinc electrode and solution is zinc sulfate solution, and right hand side blue color beaker, it containing blue color solution means copper sulfate solution, and that electrode is copper electrode. Then here the zinc it loses 2 electron and then it becomes zinc 2 plus, so loss of electron it is called as oxidation. So left hand side beaker is called as oxidation of cell. Then right hand side the copper 2 plus from the copper sulfate solution it gains 2 electron and it becomes a copper and deposited in that electrode, so gaining of electron, so that the blue color beaker cell is called as reduction of cell because it gained the electron. Now that electrode, zinc electrode is called as anode. Why it is called as anode means the electrons are liberated at the zinc electrode, so it is a negative one, so that it is called as anode. Then copper is called as cathode. Why it is called as cathode means here the electrons are consumed by the copper electrode, so it is a positive one. So the we already seen that in electrolysis cathode means negative, anode means positive, but here only in Daniel cell the anode is negative one, cathode is a positive one. Please keep it in mind because here anode the electrons are liberated, but in cathode the electrons are consumed, so that the sign is reversed. Afterward that electrolyte solution, what are electrolyte solution means in left hand side which one is electrolyte solution, zinc sulfate, and then in right hand side copper sulfate, the blue color solution. The blue color solution is called as copper sulfate. So both are connected by an inverted tube. That inverted tube is called as salt bridge. The salt bridge containing sodium sulfate and potassium chloride and agar gel. The sodium sulfate why we are using means it is a inert electrolyte, because you see that in green color I mentioned in typing in solution that zinc sulfate, the sulfate zinc plus ion is more, because the zinc metal it loses 2 electron and produces zinc 2 plus, so that the green color solution it having more number of Zn 2 plus. The same way in right hand side the blue color solution, in that one the copper 2 plus gain 2 electron and deposited in the electronoma, so that here the sulfate 2 minus ion is more. So in cathodic is a negatively charged, so we have to maintain the charges neutrality. The sodium sulfate in the salt bridge is the sodium plus moves to blue color solution and sulfate 2 minus moves to green color solution, because to maintain the neutrality. Galvanic cell notation. Now only we saw galvanic cell. It contains two compartments. One is anode compartment, another one is cathode compartment. In anode compartment it contains zinc electrode and zinc sulfate solution, and cathode compartment it contains copper electrode and copper sulfate solution. But in cell notation the zinc sulfate is not written as zinc ZnSO4. we are going to write only Zn 2 plus alone. The same way in copper sulfate also, we never write the fully copper sulfate, just we write the copper 2 plus. So how can you differentiate this electrolyte and electrode? Means by putting one vertical line. That vertical bar is indicated that it is a phase boundary. The next one, in the cathode compartment also, the copper 2 plus and copper, it is differentiated with the help of vertical line, that is called as phase boundary. And then the anode compartment and cathode compartment, they are attached by salt bridge. How can you indicate it in the notation? Means it is indicated in the double vertical bar. So double vertical bar means it is a salt bridge. Now the anode compartment, it is written on the left side, and then cathode compartment, it is written on the right side. You see the blue color below that, that anode of cell is left side ma, cathode of cell is right side. And how can you separate this one? Means with the help of salt bridge. How can you indicate the salt bridge? Double vertical bar. And then the electrode and the electrolyte, they are separated by vertical line, that is called as phase boundary. And then the standard EMF of this cell, that is written on the right hand side only, they never written on the left hand side. In anode of cell, the anode is first written, afterward the electrolyte is written. The next one, in the cathode of cell, first of all the electrolyte first of all written ma, afterward the electrode will be written on the extreme right. While reading this slide, please refer the blue color box. It will explain you each and every line. Here the reaction is given ma. From that reaction we have to write the cell notation. Here see the reaction, chromium. Chromium in the reactant side is Cr, but in product side it is become a Cr3 plus. What is happened there? They lost the electron. So loss of electron means oxidation. Always oxidation occur at the anode. So chromium will be placed on the anode compartment. The next one, from the reaction, see the reactant side, it has 3 Cu2 plus, and product side it has 3 Cu. It indicates that the copper 2 plus, it gains 2 electron and it becomes as a copper. So gaining of electron will be happen in the cathode compartment, so that copper 2 plus will be placed in the cathode. Now in chromium, it loses 3 electrons, so that Cr3 plus. But how many chromium is there? 2 chromium, so that it loses 6 electron. So that it becomes first equation. And then copper, how many copper is there? Means 3 copper. 1 copper gain 2 electron, but 3 copper means it gains how many electron? 6 electron it gains, so that it produces 3 copper. Now we are going to write the cell notation. So first of all, cell notation means anode compartment we have to write first ma. Anode compartment means which one is electrode? Chromium is a electrode. So first write the chromium. Afterward, which one is electrolyte means Cr3 plus. So differentiate with the vertical bar, one vertical bar. Afterward, cathode compartment we have to write ma. That cathode compartment, how can you write? Means with the help with the 2 vertical bar, it indicate that the salt bridge. Then after the salt bridge we have to write the cathode electrolyte solution. Which one is electrolyte here? Means copper 2 plus. After that copper 2 plus, the copper electrode we have to write at the extreme right. Then differentiate that electrolyte and the electrode with one vertical bar, that is phase boundary. This is the cell notation of the above reaction. EMF of the cell. What is EMF? Means electromotive force or the cell potential. From the Daniel cell we know there is a 2 off cell. In the 2 off cell, redox reaction will be occur spontaneously. At that one, the flow of electron will be happen from the anode to cathode. Here the force that pushes the electron away from the anode and pulls them towards the cathode, that force is called as electromotive force. That electromotive force unit, SI unit is volt V. Then the energy is produced normal, that energy is 1 joule of energy will be obtained by 1 coulomb of charges from the 1 volt difference. The 1 volt difference in the between the anode and the cathode, the 1 joule of energy is released for each 1 coulomb. Then the cell voltage, it is depends on the three factor. What are they means? Nature of electrode, concentration of electrolyte and temperature. So based on these three factor, the cell voltage will be differ by the cell, each cell. Then at 25 degrees Celsius, the Danish cell will produce the EMF 1.107 volts.